Hi, let's look at this question together. Some adults and children visited the safari over 2 days. The ratio of the number of adults to children on day 1 is 5:3. The ratio of the number of adults to children on day 2 is 3:1. There were 4 times as many visitors on day 1 as on day 2. The total number of visitors over both days were more than 1755. What is the smallest possible number of children on day 2? Okay, so let's look at the concept. Okay, just remember ratio is just a different way of representing the same fractional relationship. So if I have a ratio of A is to B is 4:5, I can also represent it in the fraction of A is 4/9 of the total and B is 5/9 of the total. And if you draw it in a model, this is how it's like. A is 4:5. A is 4 unit, B is 5 unit. Okay. In this question, I'm going to show you two solutions of how to solve the same problem. The first solution is by ratio. The second solution is by model. Let's go to solution 1. Okay, so how do we solve the problem? The number 1 is that the ratio of the number of adult to children is day 1 is 5:3. The ratio of the number of adult to children day 2 is 3:1. So you have these two pieces of information. You got adult, children, you got day 1, day 2. What you need to do is to create a table. Okay, so you have two things, adult, children. You can put it this way. You ignore the total first. I will explain later. Then you have two events, day 1 and day 2. Okay, so in this case, day 1 adult is 5:3, children, so it's 5:3. Day 2 is 3:1. So you have created the table. Once you completed that, usually we will have a third column. In this case, the third column is the total. Okay, sometimes it could be the difference, which for some question, but in this case it's the total. How do I know that it's the total? Because if you read the question just now, it talks about the total number of visitors. Okay, so they are working on totals. Okay, so in this case 5:3, you simply add up. 5, 3 is 8 and 3 plus 1 is 4. So these are the total in day 1 and total in day 2. Okay, so once you have the ratio, you can now continue on the second part of the question. The information given was that there were 4 times as many visitors on day 1 as on day 2. So it simply means that if day 2 is 4 unit, day 1 has to be 16 unit because 4 times. Okay, so now you know that your day 2 is only 8. How do you make it to 16? So I multiply by 2. So in the ratio table, the moment I multiply one of the item by 2, everything got to be multiplied by the same. So 5 times 2 give me 10, 3 times 2 give me 6, and 8 times 2 give me 16. Okay, so this is your new table. Next, we proceed. The total number of visitors on both days was more than 1755. Okay, so this is what was given, and we are supposed to find the number of students in day 2. In this case, children in day 2 is actually 1 unit. So assuming, since that we know that it's going to be more than 1755, but we do not know whether it is 1756 or 1757 and so on. So we just assume that it was 1755. So total number of visitors is actually, remember, the total is 16 and 4. So total is 20 unit. So it's 16 plus 4 is 20 unit. So 20 unit is 1755. 1 unit is 87.75. So from your answer, you know that you cannot have 87.75 children. It's just not possible. It should be either 87 or 88. So if U is equal to 87, that means there is 87 children in day 2. Total will be 1740, which is less than 1755. So this is not correct because the question says that it must be more than 1755, the total number visitors. So if U is 88, 20 times 88 is 1760, which is more than 1755, which means that this should be the correct answer. So the possible number of children in day 2 is 88. Now we're going to the second method by model. Okay, so for those who are familiar with redrawing model, let's draw the model based on this question. The ratio of the number of adult children day 1 is 5 to 3, so I draw 5 and 3 adult children. Day 2 is 3, 1, so I draw 3 unit of children, adult, and 1 unit of children. Remember, in such question, because we do not know exactly how many adult and children in day 1 and how many adult and children in day 2, the ratio is different. So in this case, I use P, 5P, and 3P. In this case, I use 3U and U. Okay, but we know that day 2 add up will equal to 4U. And we also know that day 1 is 4 times day 2. So if this is 4U, this has to be 16U. Okay, and we know the total visitor must be more than 1755 for both days. Okay, so this is how the model look like. From there, we can now solve the question. Okay, so we know that we want to find day 2, the smallest number of children. So in this case, we know that we need to find what is U. We also know that 16U plus 4U is equal to more than 1755. Okay, so we use exactly the same solution. Assuming the total visitor over both days was 1755. So 20U will give me 1755. U will be 87.75. So since we cannot have 87.75 children, it should be either 87 or 88. Let's try with 87. So 87 times 20U will give me 1740, which is less than 1755. The question says that it must be more than 1755 for the total number of visitors. So if U is 88, then I get 1760, which is more than 1755. Hence, we can conclude that the smallest number possible of children in day 2 should be 88. So this video shows you 2 methods of solving the same ratio question. I hope this is useful. If you like my video, do help me to subscribe it. Thank you.